here's problem number 23. Good news, this is an alternating series. Since it's an alternating series, it should be relatively easy to find out whether it converges. And then we'll go ahead and find out whether it converges absolutely or conditionally. So let's do the first one. Does it converge? Well, alternating series test. Using the alternating series test, we ask the question, does the limit as n approaches infinity of the nth term, clearly this goes to 0, and our conclusion therefore is the normal old series, the alternating series version, converges. Okay, so one step down, one to go. Now let's look at the absolute value, the absolute series. What happens when we take away the alternating series part of this? And what we end up getting is the series from n equal 1 to infinity of 1 over n squared there. Now what goes on with that? Let's see, what would be a good test for this? Well, I would say that this is comparable to the series 1 over n, because when 1 gets small, you get n over n squared. It looks like 1 over n, which is a known divergent series. Why is it divergent? It's divergent because it is a p-series with p equal 1. So we think this diverges, but we got to prove it. Let's prove that it diverges. So let's use the limit comparison test. Let's compare the limit as n approaches infinity of 1 plus n over n squared multiplied by the reciprocal of this, which is 1 or n squared over 1, and this, sorry, not n squared over 1, 1 over n over 1, and this limit nets out to an n squared on top and n squared on bottom is equal to 1, which is positive and finite. Since it's positive and finite, either both of these series converge or both of them diverge. This one diverges. Therefore, the series 1 or n plus 1 over n squared diverges by the limit comparison test. Alright, so we have a series that converges, but does not converge absolutely. Our conclusion, therefore, is that this series from 1 to infinity of -1 n plus 1 times 1 plus n over n squared converges conditionally. Now, what does it converge, or say, what is the limit of, if we look at 99 terms of this? Now that's a different question, so that's an error, so I'll mark this off. So really what we're asking is the error. The error is less than or equal to the next term. What is the next term? The next term is going to be, again, we'll have the absolute value, and I'll put this in, although it won't matter. It's 100 here, 1 plus 100 there, over 100 squared there. Now, the -1 part isn't going to matter, but really the error is less than 101 divided by 100 squared, which is 10,000. And that number, which means I'm shifting this over by shifting the decimal point here over by 4 zeros, gives me 0101 with a decimal point right there. And you can see that the answer we got is correct.